Hello friends, welcome to the channel Sky's the Limit. In this video we are going to discuss the another important topic of physics, that is solenoid. In order to understand solenoid, you should have the basic concept of bar magnet. So what is bar magnet? As we know that bar magnet is having north pole and the south pole, and the bar magnet produces the magnetic field around it. The magnetic field lines are generated in this directions, right? It's a closed loop. Magnetic field lines are the closed loop which emerges out of the north pole and enters to the south pole. This is the property of magnetic field lines. So here, as we move far away, the magnetic field lines will decreases. So here you can see that the magnetic field lines are parallel to each other inside the bar magnet, right? So in order to get such a type of bar magnet, what we can do is we can have one conducting circular loop, okay, which is having current I. So here in this what happens is since there is a current flowing through the conductor, it will produce the magnetic field around it. So this will be the magnetic field which is in a circular loop, okay, it forms a circular loop. Now as we know, it is in this direction, it is entering, leaving. So this is somewhat like this. So here also we can see there are parallel lines, but the width of this parallel line is much more smaller as compared to the parallel lines in case of solenoid. So therefore what we have to do is we have to introduce one more solenoid which will have its magnetic field around it, right? So it will be something like this. So at one point what happens, there are certain points at which the magnetic field lines will intersect each other. But according to the property of magnetic field lines, we know that magnetic field lines cannot intersect each other. So therefore this magnetic field lines will rearrange in such a way that it will something forms like this, okay. So here we can see these are the magnetic field lines due to different circular loops. So here they have rearranged in such a way that these lines are somewhat becoming parallel. So if we want to make these lines very parallel, what we can do is we can introduce large number of circular loops. So this circular loops, each circular loop will induce the magnetic field. This is how we can increase the width of this parallel lines, okay. So here we can see we have increased the circular loops in large number. So therefore we will get the magnetic field lines parallel inside the solenoid. So now here this is called as solenoid. Why? Because we have a circular loop closely packed to each other, right? So now here what we can see, this structure is much more similar to the bar magnet. This is north pole and this is south pole, and this magnetic field lines is similar to the bar magnet. Here solenoid means pipe and oids means shape. So solenoids means pipe shape. So here we can see this is in the shape of pipe. Hope you have understood what is solenoid. So here we cannot have it is very difficult to have the circular loops very closely lined individual, okay. So therefore what we can do is we can have one wire, okay, which is wounded in such a way in a circular loop. So this is how you can like we can wind it in this way, okay, such that this long circular loops will form to give you the solenoid. Hope you understood what is solenoid. Now here in solenoid what happens is, suppose this is the cross section of the solenoid, okay. So these are the magnetic field lines coming out of the paper, and these are moving inside the paper, and we know that inside the magnetic field, inside the solenoid, the magnetic fields are parallel to each other. Let us consider the Amperian loop inside the Amperian loop, which is which is included in this solenoid, okay. So let us consider the triangular Amperian loop, that is A B C D. So we know that Ampere's loop Ampere's circular law holds good for the closed loop only. So therefore we have considered the rectangular closed loop. Now what we know that from the Ampere's circular law, we know that the integration of B dot dl is equals to mu naught times the total current enclosed inside the conductor. Okay, so now here we have A, B, C, D, right? So this A, B, C, D can be splitted into this, which is AB, then BC, then we have CD, and we have DA. Here it is very clearly evident that AB and DC are parallel to the magnetic field lines, whereas DA and CB are perpendicular to the magnetic field lines. So therefore this whole integral of this triangular loop can be split in this way. And since we know that B dot dl, it is a dot product, that is integration of B dot dl is equals to B dl cos theta, since it is a dot product. Now if it depends on the theta value. If suppose the magnetic field lines and the length element are perpendicular to each other, then the integral of B dot dl will be equal to 0. If they are parallel, that is theta will be equal to 0 degree, we will get the value for B dot dl. Okay, so therefore here we know that B dot dl, that is B dl cos theta, if theta is equals to 0 degree, then that means they are parallel. So here DC and AB, right, they are parallel, that is AB and DC or CD are parallel to each other. So therefore this theta will be equal to 0, cos 0 is 1, we will get B dl is equals to BL. And next, due to the perpendicular components, that is CD and DA, since it is forming the 90 degree, that is cos 90 is equals to 0, B dot dl cos 90 is 0, we will get this integral, that is D is 0, and we have CD. CD will also be, CB will also be equal to 0. Only the total magnetic field will be due to the current element of AB and CD. Hope you have understood till here. Then from the Ampere's circular law, we know that integral over the closed loop ABCD is B dot dl is equals to mu naught times the total current through the closed loop. Okay, so here if suppose L is the length of the solenoid, that is this is the length, let's consider this is the length, and the total current enclosed here is I. So therefore we can write it is mu naught n number times of L into I, that is equals to B is equals to mu naught Ni. So this is very important expression for solenoid. What it is, magnetic field is equals to mu naught Ni. This will be asked in a multiple choice questions, that what is the formula for solenoid. So it is clearly mu naught is equals to B is equals to mu naught Ni, where N is the number of turns and I is your total current enclosed. Hope you have understood what is solenoid. So basically solenoid, it is the long conducting circularly wounded wires, okay, which is insulated from each other. They are not connected to each other like there is insulation, okay, so that there is no loss of current or loss of anything. So therefore we can say that solenoid is nothing but it is the long circularly closely lying circular loops, okay, through which the magnetic field will, through which the electric field will pass. If the electric field is passing through the, if the electric field is passing through this wire, then it will produce the magnetic field around it, and that the magnetic field around it is given by mu naught Ni. Hope you have understood. So similar to the solenoid, we have another concept, that is toroid. For toroid also, it is very similar to the solenoid. In case of toroid, what we do is, if suppose this is the your solenoid, that is it is a straight, right? So what you can do is you can take the end, both the ends of the solenoid, and you can bend it, okay, bend it, when you bend, what we will find? We will find something like this, right? So this is when you bend the two ends of the solenoid like this, we will get what? Toroid. And the expression for toroid is also given by mu naught Ni, which is similar to solenoid. Hope you have understood what is solenoid and what is toroid. Okay, so this will be asked for 1 marks for sure in your HSTR or your GPSTR, and this is as per the syllabus of HSTR and GPSTR. Also, this is included in the second PUC, okay, syllabus of second PUC. So hope you have understood. Please subscribe to my channel if you haven't. Like the video and share with your friends. Thank you.